Hello students, welcome to Sri Jayendra's Ring Zone classes. I am your friend and mentor for coming classes with respect to physics. This is lecture number 5 of a unit mechanical properties of fluids. So let's begin with today's class. In the previous class we were discussing the Bernoulli's principle, and even we have discussed certain applications of the Bernoulli's principle such as the Venturi meter or blood flow and heart attack, a Magnus effect, aerodynamic lift, and all that. Now we are moving ahead with the certain few Bernoulli's applications that we have not discussed in the last class. So let's begin. Now let's suppose, look at this application in a question point of view, that let's suppose this is the situation, that this is the pipe having non-uniform cross-sectional area, and this is the reference level. Let's suppose this is at height h, as it is the horizontal pipe. As it is the horizontal pipe, it is at the same horizontal level. As you can see here, it's a cross sectional area A1, velocity V1. This is cross sectional area A2 and velocity V2. If you need to write down the Bernoulli's principle at these 2 points, it's a point number 1 and point number 2, what you will write? Tell me. So the Bernoulli's principle on this two locations, Bernoulli's principle on this two locations will be equals to, it's a P1 plus half rho V1 square plus rho GH. That should be is equals to P2 plus half rho V2 square plus rho GH. This would be the Bernoulli's principle for these 2 points, or I should say for a horizontal pipe. When this pipe is horizontal, this and this 2 is going to cancel, and if this 2 is going to cancel, it would be P1 plus half rho V1 square. That should be is equals to P2 plus half rho V2 square, or I should say it's a pressure plus half rho V square is equals to constant. I hope this is clear. It is the pressure plus half rho V square is equals to constant. Does it clear? Does it clear? Now this is having a very applications, this is having a very wide range of applications. It's a P plus half rho V square is equals to constant. So from this, if at a certain region, if at a certain region velocity of fluid is higher, pressure in that region, pressure in that region will be lower, or even a reverse of this could be said, that if at certain region, if at certain region velocity of fluid is lower than pressure in that region will be higher. I hope this is clear. So it's a P plus half rho V square. It's a P plus half rho V square, that would be equals to constant. Now, now let's look at this logical question. Let's suppose this is the pipe, and as you can see this is the cross sectional area A1, this is the cross sectional area A2, this is velocity V1, this is velocity V2, and fluid must have passed through this. Let's suppose this is the point 1, this is the point 2. If someone asks me that what should be the relation of pressures, whether P1 greater than P2 or P1 less than P2, or it would be a P1 equals to P2, what would be the situation? So what should I do? As you can see this for a horizontal pipe. First thing, it's a horizontal pipe. So for a horizontal pipe, P plus half rho V square is equals to constant. Yes, agree with this? Yes, no. Yes, do you agree with this? Great. Now, according to the equation of continuity, I understand that A1 V1 is equals to A2 V2. And as I can see it that A2 is greater than A1, that means V2, it's a velocity at point 2 would be less than velocity at point 1. And if velocity at point 2 is lower, that means pressure at that point must be higher. So P2 must be greater than P1. Yes, this is to be understood. Now, some of you might made a mistake that, sir, you told us that pressure on the same horizontal level would be equal. Yes, you are absolutely correct. I have told that, but I have told even that this is to be applicable when fluid is at rest. And here fluid is in motion. It was fluid statics. This is fluid dynamics. I hope you understand and differentiate these two things. Have you? Have you understand these two things and difference between this? I hope this is clear. So this is the situation where pressure would be higher. It's a P2 which is greater than P1. I hope this is clear. Is it clear? Is it clear? Great. Now let's look at the next question based on this application. Let's suppose this is one of the home of certain villages, and these roofs are not the strong enough to sustain a high speed wind. Let's suppose a wind has been blown in this direction with a speed of, let's suppose that speed would be equals to, it is the 2 kilometer, or I should say the wind that is flowing from this, it's 40 meter per second, and the wind that has been flown through this, it is very nominal, that is what we can say, it's 2 meter per second. This is inside the house. Let's suppose understand that density of air, it's let's say it's a 2 kg per meter cube. So they will ask me, find out pressure difference developed in on the roof. So what you need to do is, let's assume that this is the point. Let's call this as a point 1, and let's call this as a point 2. This point 1 is just below the roof. That is, we can say it's within the home. And this point 2 is just above the home. It is above the home. So if I consider this two on the same height, they are approximately on the same height. So what I can do is that I can have this relation, it's a P1 plus half rho V1 square. This is equals to P2 plus half into rho into V2 square. And from this, it's a pressure difference of P1 minus P2, which could be given as half into rho into V2 square minus half into rho into V1 square. This was the situation. So if this was the situation, this is P1 minus P2, which is equals to 1 by 2 into rho. It's a 2 into bracket V2 square minus of V1 square. From this 2 has gone, and this is equals to 1 into bracket V2 square minus V1 square. This is equals to 2 square minus of 40 square. I hope this is clear. And this is equals to P1 minus P2. So this could be given as, it's a P1 minus P2. This is equals to 2 square, it's a 4, minus 40 square, it's a 600. So this is equals to minus of 1596. This is equals to P1 minus P2. And from this, it can be said that P2 minus P1, this pressure difference is 1596. Let me redraw the situation, that it was the situation, and I have considered the point 1 over here, I have considered the point 2 over here. I hope this is clear. Is it clear? Is it clear? Are you sure? Are you sure? This is the pressure difference between 2 points of a roof. I hope this is clear. So can you do this kind of questions? P plus half rho v square. P plus half rho v square is equals to constant. I hope this is clear, and this is having a very good applications. Now let's discuss a next and very important application of Bernoulli's principle, that is velocity of E flux. This is having a this is having the maximum number of numericals when we ask about the Bernoulli's principle. So please have a focus on this and look at this very carefully. Let's have a look. The velocity of efflux, that how could I calculate it? Let's suppose the situation is, it is something like this, that it's a Torricelli's law, and we can say it's a efflux. The word efflux means fluid outflow, and Torricelli has discovered that the speed of efflux from an open tank, that is given by a formula which is identical to that is of a freely falling body. So how he has derived this, let's have a look and let's understand that. Let's suppose consider a tank that is containing a liquid of density rho. This liquid is having the density of rho with a small hole in its side. Here it is the hole, and that hole is made up at a height y1 from the bottom, and that hole is at from height h from the top of the liquid that have been filled up. The total amount of liquid, the total height of the liquid actually is y2, and let's assume that this is the point 1, this is the cross sectional area a1, this is the cross sectional area of this tank, and pressure at this, it's a p2, area is a2. Same way here, pressure, it is a pa, and here cross sectional area of this hole is a1. I hope this is clear. So from equation of continuity, we can have this relation that a1 v1 must be is equals to a2 v2, and from this it's a v2 that is equals to a1 by a2 into v1. Now as I understand that, look, after even the observation that a2 is much greater than a1. As you can see, this is the area of the base of the tank, or the, and this is the area of the hole. So area 2 is much greater than a1, and as area 2 is much greater than a1, this v2 would be approximately 0, because it is considered at approximately at rest when it is the top of the layer. Now let's apply Bernoulli's principle at point 1 and 2, and noting that at the hole is the at atmospheric pressure. That's why I call it, it's a P1 that should be is equals to PA. Now let's write this, it's a pressure A, it's atmospheric pressure, plus half rho V1 square plus rho G Y1, that is equals to P plus half rho V2 square plus rho G Y2. Now if I suppose to take this Y2 minus Y1, let's have a look. It's this is the Y2 and this is the y1, this has been taken as an h, so this y2 minus y1 is equals to h, and from this if I solve this, I am having this relation, it's a v1 which is equals to root of 2gs plus 2 into bracket p minus pa divided by density whole under the square root. Yes, this is the velocity. Now if I consider that if p is much greater than pa, and let's suppose that 2gh, if 2gh may be ignored, the speed of efflux is determined by the container pressure. This is the one of the case when when the pressure is much greater than atmospheric pressure. But on the other hand, even this could be the case that tank is open, and if tank is open to the atmosphere, this would be the situation. Let me show you that this is the tank, and now it is open. This is the fluid with which it has been filled, and this is the hole where they have made it, it's a 2, and h is the height from the top. So if I'm going to ignore this, it's PA, this is PA, this 2 would be cancelled out, this is 0, so this term has been gone, and this V1 equals to root of 2GS. This equation is known as the Torricelli's law. I hope this is clear. Is it clear? Is it clear? So now we have been with two relations, and the two different relations, let's evaluate them in a proper manner, that this was the situation. Initially we will think that it is about the closed container, and from here we have made up the hole. This is height h, where from where we have made up the hole, and this is the fluid with which it has been filled, something like this. So velocity I received, it's root of 2gh plus 2 into bracket p minus pa divided by density. So this velocity, if I observed correctly, then this velocity of closed container, velocity, sorry, velocity of fluid in the case of closed container is V directly proposed into the h, again root of h. This depends on the pressure difference, it's a P minus PM, as well as it depends on the nature of the fluid, because it depends on the density. So this depends on the nature of fluid. Basically it depends on the density. This is what I mean. Now let's take the second case in which my container is open. It is something like this. This was the container, and if it is the container, this is the fluid with which it has been filled, and I have made a hole over here, and this is at height h. So it is the case of the open container, where V I received, it's a root of 2 into g into h. This is velocity what we received. So this depends on this velocity of fluid depends on, that is V directly proportional to the root of h. That's it. It's height of hole from the top. This V does not depend, this does not depend on the nature of fluid. So it does not depend on the density, neither density nor viscosity and everything. It doesn't know. It know only the height from the top. I hope this is clear. Is it clear? Is it? So this V directly proportional to the root of h. Is it clear up till now? Do you have any doubts? Is there anything? Is there? No? So now ready for the questions? Ready? Let's have a look. Suppose the question says that, let's suppose this is the container, and on this container we have made up a hole over here. This is at h is equals to 10 meter from the top, and this is filled with the water. Water is coming out from this, and this is what we call as a V1. Now in a next container, we have honey with us. We have made up a hole over here, and this is again at height of 10 meter. honey is coming out from this, and this is V2, let's say. So the question asks me that find out ratio of V1 is to V2. So as both are the open container, this is water and this is the case of the honey. Both are the open container, and as this both are the open container, their velocity would be given as v1, it's a root of 2 into g into h1, while v2, that is equals to root of 2 into g into h2. Now as you can see, 2 would be always equal gr equal h1, it's a 10 meter, h2 it's a 10 meter. So when I take a ratio of this, it's a 1 is to 1. I have demonstrated this example to again make you understand that they does not depend on the nature of the fluid, provided container is open. When container is closed, they will specifically inform you that it is the case of the closed container. It means if they have not asked anything that this container is open or this container is closed, something like that, it means they want that it is by default open container. I hope this is clear. So if they have not mentioned anything that whether this container is open or whether this container is closed, it means they are talking about open container. It is the default instructions. I hope this is clear. Is it clear? Is it great? So ready for the next question? Let's have a look. Suppose the situation is something like this. This is the container and it is having a hole over here. This is height h and this container is filled with the water up to this, something like this. Yes, this is height capital H up to which it has been filled. So first question is that find out velocity of efflux. So what we are supposed to do is that we understand that as I have made hole over here, so water will coming out and it will strike to the land over here. So I need to find out the velocity. This velocity v could be given as v is equals to root of 2 into g into h, and yes, your task is over. That's it, you did it. It was the first task, find out velocity of efflux. Now let's move on to the second task, find out range of water. How will I do this? It is simply a jump from the mechanical properties of fluid to the motion in a plane. Yes, it's a bigger and longer jump. How will I do this? So what I understand is this was the first. Now let's work for the second. I need to find out the range of the fluid. So this is the range. First thing, how will I calculate this? This is h minus h. Yes, and the range would be always velocity in horizontal direction multiplied by time of flight. So now velocity in horizontal direction, that you have already decided, so v equals to root of 2gs multiplied by time of flight. Now how should I calculate time of flight? Time of flight could be given as h minus h is the distance to travel is equals to half into gt square. So from this it's a t which is equals to root of 2 into bracket h minus h by g. So this range v is equals to root of 2 into g into h multiplied by root of 2 into bracket h minus h by g. This g and this g has been over, and whatever I have been left is with the range. So range of a efflux could be given as, it was the situation that it is under root of 2 into h multiplied by 2 into bracket h minus h. So this is equals to 2 2s are 4, and let's keep it outside the square root. It's a 2 multiplied by root of h into bracket h minus h. This is range. I hope this is clear. So this was the range. This was the range of this efflux or the fluid that is leaving out from the container from that hole. I hope this is clear. Is it clear? Is it clear? Are you sure? Now, shall I extend this question? Shall I? Let's have a look that if we want to find out maximum range where hole should be made, if we want to have a maximum range, where should be the location of the hole? This is what the question is. That's Let's understand the situation one more time. This was the container and it has been filled with the water, and this water has been filled up to height h. You have made a hole from somewhere here. This is h. So what they ask is you can change this position of hole from upward or downward, whatever you want, but this range should be maximum possible. This is the requirement is. How will you do this? Take your time of 30 seconds and let me know what to do and how to do. What will you do? What I understand and what I suggest is that we are having the range something like this, that range is equals to, it's a 2 under root of h into bracket h minus h. So it's an r square which is equals to 2 into h into bracket h minus h. Let's use the concept of minima maxima, that in the what I want this r square maximum and with respect to h. So what I'm supposed to do is it's a d by dh of r square. So this is equals to d by dh of 2 into bracket, this is equals to hh minus of h square, and that should be equals to 0. That should be is equals to 0. So if this is the situation, this would be the d by dh of h into h minus of h square, that should be equals to 0. If this is the situation, then it would be a d by dh of hh minus d by dh of h square, that would be equals to 0. So this is equals to h minus of 2h, that should be equals to 0. And from this it is h equals to 2h, and from this it is h should be at the h by 2. So if hole is made up at half of the height, when I say half of the height, that means it's at half of the liquid which has been filled, then range achieved will be maximum. I hope this is clear. Is it clear? Is it? Are you sure? So if I'm going to hold it at half of the height, then the range achieved will be the maximum. I hope this is clear. Is it clear? Great. Now let's work for the question. Let's suppose the situation is this has been filled with the contain filled with the liquid. This is the 10 meter which we have filled up the fluid, and hole has been made up at this position. This is the 5 meter. As you can see this, we have made up this hole at half of the height. So whatever the range will be, it would be the maximum. Yes. So they will ask me that find out range of efflux. So to find out the range, what I need, it's a horizontal direction velocity multiplied by time of flight. Horizontal direction velocity, it's a 2 into g into h multiplied by time of flight, which is equals to 2 into bracket h minus h by g. This is the range. I hope this is clear. So this g gone, and the range would be equals to 2 and 2. It's a 2 into bracket root of h into bracket h minus h. I hope this is clear. So from this, it's a 2 into bracket h, it's a 5 into bracket h minus h, it's a 10 minus 5, it's a 5 again. So it's a 5 5 25 multiplied by 5 when I'm kept it outside the square root. So this will be the 10 meter. I am having the range of 10 meter. I hope this is clear. This would be the 10 meter. I hope this is clear. Is it clear? Is it? Are you sure? Are you? So now let's have one more research on this range theory. So let's have a look. Let's suppose this is the container, and this container has been filled with the fluid. It is something like this. And let's call this as a 10 meter. Now at this point of time, you have made up a two holes, one at here and one at here. This is at 2 meter from the top, and this is at 2 meter from the bottom. Let's suppose you have been asked that this is, let's call this as a range 1, and let's suppose this as a range 2. The question is find out ratio of this ranges R1 is to R2. You need to do this. Just do it. So what do we understand is, let's suppose range 1, it's a 2 under root of h into bracket h minus h. I hope this is clear. So this is equals to 2 under root of h. So when this height 2 meter, when, okay, yes, this is 1. When this height is 2 meter from the top, it's a 2 into bracket h minus h. This is h minus h. For this case, it's a 10 minus 2, which is equals to 6, or 10 minus 2, it's an 8, sorry. So this is 2 under root of 2 into 8, 16. When it is a square root of 16, it is 4. So this is equals to 2 into 4, which will be an 8 meter. This is R1. And let's talk about the R2, what it is. So if I try to find out the R2, that is equals to 2 multiplied by, let me rewrite. This R2 would be equals to, it's a 2 multiplied by h into bracket h minus h. This is equals to 2 under root of this height. This is 2 meter, but this is from bottom, so you need to calculate it from the top. This will be 8 multiplied by h minus h. Yes, this is 10, this is 2, it's an 2. So this is equals to 2 into 4, this is equals to 8. It's a surprise that both are having same ranges. Both are having same ranges. So is it happen every time, or it is just a coincidence? What do you think? What do you think? This range depends only this many terms, this many. It depends on the h. It depends on the h minus h. Yes, and a biggest thing is this two are in multiplicative term. That means either you do 4 into 3 or you do 3 into 4. Both will be result to a 12 number only. I hope you understand this. So this is not just the sequences. This is not just the coincidence. This is going to happen every time. This is going to happen every time. Let's summarize this application. That, let's suppose this is the container, and this container is filled with the fluid, something like this. as this container is filled with the fluid, and let's suppose this height is h. Suppose you made up one of the hole over here, and this is height y, and you made up one of the hole over here, this is the height, this is the y from the bottom, this is from top, this is from bottom. So you can say from the top this is h minus y. So in this situation, whatever the range you are going to receive would be the same. Yes, it is possible that it may not be the maximum range. I hope you understand this. I'm not telling this that this would be the maximum range. No, it is possible that this may not be the maximum range. But this is for sure. This is for sure that this would be the range having the same value. I hope this is clear. Is it clear? So let me write down this, that if we make a hole such that distance of that holes are equal from top and from bottom, then range of the fluid leaving the container, range of the fluid leaving the container would be always equal. Please keep this in mind. This two range would be equal. They are going to land on the same location. But for that, if you have made a punch this from 3 meter, even from the bottom, you need to punch this at a 3. Then in this situation, their ranges would be always equal. Definitely 100% every time, each time. I hope you remember this and you will understand this. Clear? Great. Let's work on for the next question. Let's suppose now we are rearranging our situations. At this point of time, we are having one of the stool. That means we are having one of the stand. We can say this. And on we have put our container on this stand. And this container is filled with, let's say, fluid. The stand is of height of 5 meter. This is the height of the stand. And even this is being filled with the height of 5 meter. And you have made up a hole over here. So this will move like this. So it is going to strike at this point on the floor. Let's call this point as a P. So the question is find out velocity of fluid at point P. When I say at point P, that means when it strikes the surface of the earth. This is the situation. How will I do this? So first what I must understand is that when it is going to be strike at here, it is having two velocities. One, it's a v1, another it's a v2. This two velocities would be there, and this is the velocity, it's a v1. It's basically it's a horizontal projectile. I hope you understand this. And in the case of an horizontal projectile, we have learned that the velocity of x component is never changes, even not in the horizontal projectile, in every projectile velocity of the x components never changes. So what I need to do is I need to find out v, which is equals to under root of v1 square plus v2 square, because angle between these two is 90 degree. So let's keep this task one by one. First find out the v1 and then we will switch to the next task. So v1 could be given as v1, it's a 2gh, and this is equals to 2 multiplied by g, it's a 10, height is the 5, it's a 2 5 is a 10, it's a 10 10 100, and it would be a 10 meter per second. I hope this is clear. Now let's try for this V2. How will I do this? Because if you look at this position here, velocity in y direction is 0. So when velocity in y direction is 0, you can write this. It's a v square minus of u square equals to 2gh. And from this, it's a v2 square equals to 2 into g into h. This will be 2 into 10 into this height of a stand. It's a 5. So it's a v2 will be equals to 5 meter per second. It's a 2 5s at, sorry, 10 meter per second. My mistake. I hope this is clear. So now I am having this v1. I am having this v2. This both the relations are there. This both relations are there. What I can get is that it is just the under root of 10 square plus 10 square, and this is equals to 10 root 2 meter per second. I hope this is clear. Was it clear? Was it? Are you sure? Are you sure? Great. Well done. You did a great job. Shall I extend this question? Shall I? So, the question is that find range of the fluid in the previous question. We need to find out the range. How will I do this? What could be done? Let's have a look. That I need to find out this range. So basically again horizontal direction velocity, which is v1, and time of flight, it's a time of flight to travel this distance. I hope this is clear. So let's begin. Very easy task. It's a range. It is the horizontal direction velocity multiplied by time of flight. When I say horizontal direction velocity, it is simply the root of 2gh multiplied by time of flight multiplied by time of flight. In this case this is this height. It is root of 2 into 5 divided by g. It's a 10. So this can gone, and this 2 and 2, this is 2 multiplied by this h. This is the 5 meter. By coincidence, this all heights are equal, but I am not writing the same relation. Please keep this in mind. So this is equals to 2 under root of 5 multiplied by this 5. Sorry, I hope this is clear. Give me a moment. So this is going to be range is equals to 2 under root of 5 into 5, which is equals to 2 into 5, which is equals to 10 meter. I hope this is clear. Is it clear? Is it? Are you done with this? Are you? Do you have any doubts up till now? Is there anything? Is there? Do you have any doubts? Is there anything? No? Is there anything? No? Great. Let's look at this question. Suppose the container is there and container is filled with certain fluid in it. This is the situation, and we have made up, let's say, a hole over this, and water is flowing in this direction and it strikes the flow. This is height h, this is height capital H. The question is, listen this question very carefully, very interesting, that does container shifts in backward direction due to fluid coming out from the hole? This is the question. Let's suppose that this is smooth surface. This container has been placed on the smooth surface. No friction will be there. So it says does container shifts in backward direction due to the fluid coming out from the hole. Does it? What do you think? What is your opinion in this? Does it shifts in the backward direction because this fluid is leaving this hole? If your answer is no, if your answer is no, no sir, this is not possible at all, then please listen me very carefully. Have you remember that we have done the questions of the gun and bullet, something like this? Yes. So the bullets were leaving the gun. So bullets were moving in the forward direction, but this gun is moving in the backward direction. Yes, no? Yes. Then why this tank or why this container cannot shift in the backward direction if this fluid is moving in the forward direction? I hope you understand this. Have you understood this? Do you? Yes, no, yes, correct. So what I understood is that yes, due to force of reaction, it will shifts in the backward direction. It will shifts in the backward direction. This will be the situation. Yes, it is absolutely happen. So now the second question he will ask is find out amount of force acting on the container. That what amount of force is acting on the container. So what I understand is that this force will be equals to rho into A into V square, where rho it's a density of fluid, A it's a cross sectional area of hole, and velocity it's a velocity of fluid. You have done this in the laws of motion. This force will be equals to rho a v square. Let's replace the value of v square, which is equals to 2 into g into h. This is the force acting, and due to this force acting, this tank will shift in this direction because this fluid is moving in the forward direction. I hope this is clear. Please have remember this case. This is very interesting and this is very important topic. I hope this is clear. Is it? Let's have a question, one more question based on this. Let's suppose this is the situation that this is the container, and if this is the container, let's suppose this is the first hole that you made up over here, and let's understand that this is the second hole you made up over here. When you made up this two holes, this is at height h1 and this is at height h2, and we can say that the difference between these two holes, let me show you a difference. One moment. Yes, the difference between these two holes would be, let's say, x. So the question is find out net force acting find out net force acting on the container as fluids will be leaving from the holes. So how will we do this? So fluid is leaving from here, even a fluid is leaving from here. This was, let's call this force 1, let's call this force 2. Due to this force, this tank will shift in this direction, and due to this force, tank will shift in this direction. So let's write down first both the forces. This F1 could be written as a rho into A into V1 square. This is equals to rho into A into V1 square. This is equals to 2 into G into H1. Let's write down the another force. It's an F2, which is equals to rho into A into V2 square. And when it is rho into A into V2 square, this is simply the rho into A multiplied by 2 into G into H2. I hope this is clear. As I understand that this H1 is higher the H2, that means F net. This F net could be given as this is equals to F1 minus of F2, and this F net is equals to F1 minus F2. Then this could be written, or this should be written as rho into A into 2G multiplied by H1 minus of H2, or I should say it's a 2 into rho into A into G into H1 minus H2. It's an X. This is F net. I hope this is clear. Is it clear? Is it clear? Are you sure? Great. So now let's empty the tank and finish this application. It is time to empty the container. So now let's suppose the situation is something like this, that this is the container, and as it has been filled with the fluid, this is the situation. We have made a hole at its bottom at this point. Let's suppose this is H. I need to find out the time to empty the tank. How will I do this? How will I do this? Let's suppose area of hole is, let's use it as an A, and area of bottom of container, it's, let's talk about the capital A. Now you need to find out that what amount of time will it take to completely empty this tank. So basically what happens, that if you understand the situation, that this, we have made up a hole over here, and as soon as this water is leaving from this tank, water is leaving, that means this h will decreasing, and this h will decreasing, the speed will decreasing, because v is equals to root of 2gh, and in this situation h is only the height, and which is decreasing. So what we need to do is, let's consider at certain instant of time, at certain instant of time we have y height of water filled in the tank. So we have y height of water in the tank, and in this situation, the speed of the fluid leaving the hole, it's a fluid of, that is, that's the speed of the fluid, that is the speed of the fluid coming out of the hole, is root of 2gy. I hope this is clear. Now from the, according to the equation of continuity, this is a1 v1, this is equals to a2 v2, and from this a1 it's a root of 2 into g into y multiplied by this is velocity multiplied by cross sectional area A Minus of this is minus of a multiplied by dy by dt is decreasing. Why this minus? Because it is decreasing. So from this it would be minus of a by a from 0 to t, it's a dt. I have rearranged this. This is equals to, this is equals to integration of, this is equals to integration of h initial to h final dy divide by root of 2 into g into y. So if I put the limit, if I put the limit and get it done, then this could be written as t is equals to a by a under root of 2 by g multiplied by this is hi minus h initial to the h final. I hope this is clear. Is it clear? Yes. So this time could be given as, if I check the dependency, then this could be written as this is equals to, this is equals to under root of hi minus root of hf. This is the final formula if only the height has been changed and everything else remains the constant. I hope this is clear. Is it clear? Is it? Do you understand this? Have you understand this? Have you any doubts up till now? Is there any doubts? No? So can you do one question based on it? Let's have a look. Let's suppose, understand the situation well. This is the situation that, let's suppose this is 40 centimeter. It has filled up with, it has been filled up with this fluid, and we have made up a hole at bottom. We have made up a hole at the bottom. So they will say that find out ratio to empty the first half and second half of the tank. We need to find out the ratio to empty the first half and second half of the tank. So this complete is a 40 centimeter. Let's assume this is a 20 centimeter. So this is first half and this is remaining 20 centimeter. This is second half. Let's call this time as a t1 and let's call this time as a t2. So from this what I understand is that t is directly proportional to the root of h initial minus root of h final. So for the first half h initial it's a 40 centimeter and h final level would be a 20 centimeter, and for the second half this h initial will be a 20 centimeter. This all are in the centimeter, and h final it would be equals to a 0 centimeter. So from this I can have a relation which is equals to t1 is to t2, that is equals to, that is equals to under root of 40 minus root of 20 divide by root of 20 minus root of 0. It's a root of 20 as a common, this is common, and this is equals to root 2 minus 1 divide by root of 20. So this has gone, this is equals to root 2 minus 1. This is the ratio t1 is to t2. I hope this is clear. Is it clear? Do you understand this? Have you completely? Any doubts? Is there anything? No? Great. Let's just wind up this session over here. This was all about Bernoulli's applications. This is a very wide topic. It is having a very large number of applications. So it was not possible to cover everything, but I have tried my best to complete and the cover at least maximum of it. So please do as many questions as possible. And this questions, this applications will help us to get the numericals done. Thank you. Have a good day. Take care.